Hello everyone, today we are going to talk about quadratic functions and models. We're going to start chapter 3. So first, let's write down what is quadratic function. Quadratic function is f of x equals a x squared plus b x plus c. It's called quadratic function in case a is not equal to 0, a real number. Also, b and c are real numbers too. How do we graph quadratic function? Well, first, why do we call it quadratic? Because it's a square. Square in Greek is a quadra. No, in Greek it's tetra. Quadra it's in Latin. Sorry, a little mistake. Okay, well, we're going to consider several steps in graphing quadratic functions. Number one, we're going to start with simple parabola. How do we graph parabola? Usually we graph coordinate axis, x, y, label one here, and kind of you can make 3 points, origin and 1, 1, and try to graph the shape of the parabola. Something like this, right? Step number 2. So this is a graph of just x squared. Step number 2. What if you want to graph f equals a x squared? X squared multiplied by a. Remember that when we multiply function by a number, we are going to stretch or squeeze in y direction. Well, I don't know. I'm going to just draw general picture in this case. And for particular a, you will need to decide which way you kind of stretch or shrink the graph. Well, let's imagine that we have a over here. I don't know what is going to be a. A can be 2, can be 5, can be 1 over 2, and we have 1 over here. So if you look at my scale, obvious from my graph that a equals actually 2, but normally can be anything. Same origin is at origin, and we are going to have a shape looking like this. Well, again, why it's going to look like this? Because if you plug in 1 here, you are going to have f equals a, which is going to give you this picture. Number 3, I'm going to modify it a little bit. Now I'm going to graph f of x equals a x minus h squared. So how did I modify the previous one? In parentheses with x, I subtracted h. We remember from graphing that in this case, we are supposed to shift our graph h units to the right? Well, let's kind of see how it's going to look now. Well, I don't know what is h. H can be like positive or negative number. I'm going to choose positive h. My h is here. This is my 1, my x, this is my y, and that's going to be my a. Also, I don't know what is a. From my picture, it's obvious that both h and a are equal to 2, but they can be any numbers. So first, the vertex, which was over here, now is going to be here, right? The point which was like 1 unit away from the vertex was at a level. 1 unit away to the left from the vertex at a level. And we are going to have something like this. Well, again, I just took this parabola and shifted it h units to the right. It can be like positive number or negative. If it's negative number, we are shifting 8 units to the left. Next transformation we are going to apply to our parabola. Number 4 is going to be a x minus, sorry, I was trying to write down a plus minus h squared plus k. Well, when we take the whole function, which we had before, right, and add something to the whole function, we are going to shift it in vertical directions. So we are going to shift it k units up. Well, besides k units up, we are going to have h units to the right, and we are going to stretch a units like along y-axis. I'm going to write down y-axis stretch. well, the graph is going to look unit here, x here, y here, also 1 unit here. So we'll need to do kind of 3 things, k and h. Well, my h I'm going to keep the same way here as here. I don't know what to do with k. Well, let's do k over here. K over here. So the vertex is now going to be here, right? K units up and h units to the right. Now my a, well, I'm going to keep still like same a like we have over here. So it's 2 units. So I'm going to have points over here. And my parabola is going to look like this. Well, not very difficult. Basically, guys, no one is going to ask you like whether your parabola is squeezed or stretched like enough. Usually, if you kind of graph a shape of parabola, everyone is going to be okay. But for the vertex, you will need to know where to put the vertex. So I'm going to write down that the vertex, which is going to be this point, is going to have coordinates h, k, which are going to be coming from here and from here. The form which we have over here is called a standard form of a parabola. I'm going to write down a standard form. Now, usually, parabola is not going to be given in a standard form. Usually, guys, somebody is going to give you a parabola looking like this. So how do we bring it to a standard form? I'm going to do it once on particular numbers and once in general. You choose which way you are going to use, and then I'll give you the formula actually. Okay. So if you have your parabola like this, you know where is the vertex and you know how approximately the shape is going to look, and that's basically all you need to know. Example. I'm going to do parabola ax squared plus bx plus c into a standard form ax minus h squared plus k. I'm going to consider like particular parabola. So my f of x in this case is going to be 2x squared plus 4x plus 8. So my a is 2, my b is 4, and my c is 8. So I'm going to show you the steps how we modify this parabola to bring it to a standard form. I'm going to do every next step below the previous one. So first, guys, we are going to consider these first two terms and take the coefficient 2 outside of them. So 2, and here x squared plus 2x. 8 is going to just stand by itself. So I took 2 units from here and 2 units from here. Next step, I'm going to complete the square in parentheses. What means complete the square? What is missing to complete the square here? I know that like if it's a plus b squared, I'm going to have a squared plus 2ab plus b squared, right? I know that my a here is kind of x from over here, right? Now, what is going to be my b? If this is x, then this 2b is going to be equal to just 2, right? So b from here is going to be equal to 1. It's just like I divide 2 over 2. So that's what I'm going to do. I'm going to add 1 square. To not change it, I'm going to subtract 1 square right away and keep writing down this plus 8. Next step. Well, because I already did the perfect square, I'm going to roll it into a perfect square. X plus 1. That's my perfect square. 3 terms over here. I think I'll change the color. I'm going to. Now, minus 1 is going to stay as minus 1 plus 8. I'm going to modify a little bit this expression, opening now parentheses with 2. I'm going to keep 2 in front and multiply by these parentheses, not opening them because I just rolled them. And 2 by negative 1 is minus 2 and plus 8. And I'm going to modify it a little bit more. I'm going to write down 2x plus 1 squared, and 8 minus 2 is 6. And you see that my parabola now is in a standard form, and in the standard form a equals 2, h equals what? -1, because we're supposed to subtract h, but if we add it, we are kind of subtracting -1, right? And k equals 6. So I'm going to write down that vertex is going to have coordinates -1, 6. And that's going to be stretched 2 times. I'm going to graph it and do the same equation in general, okay? So let's imagine that this is 1, this is -1. Let's imagine that this is 6. I don't want to do 6 over here, too high for me. So 1 over on y-axis is over here. I know that's a little bit unfair, right? X is going to be much like bigger scale than y, but to make 6 over here, it's like 2, 3, 4, 5, and 6. So that's going to be my vertex. My vertex coordinates -1, 6. And then what you can do, guys, you can calculate 2 more points or 1 more point and make a reflection of it. For example, you can step away 1 unit in x direction to the right. And over here, plug in 0, because 0 is 1 unit to the right from -1, 0. What are you going to have? If you plug in 0 here, it's 1 squared, which is 1, multiplied by 2 is 2, plus 6 is going to give you 8. So you just kind of get 8 over here. And you can grab the symmetrical point over here, and that's how your parabola is going to look. That's going to be the graph. Okay. Now, before I kind of prove it in general, I want to do some more like examples and then move to general formula. I'm going to show you general formula, how you can kind of complete this square without actually completing the square. But first, let's talk about intercepts. Well, what kind of intercepts we can have? We can have y-intercept when x is equal to 0. Do we have y-intercept here? Yes, here is y-intercept. Intersects x-axis and actually happens when x equals to 0. In our case, y equals 8, x equals 0. There are also x-intercept. X-intercept is opposite. That's y equals 0. Y equals 0 means that they are intersecting x-axis. We don't have any x-intercepts on this graph because the graph does not intersect x-axis. But sometimes it's going to do this, sometimes no. And for this specific one, we have no x-intercepts. But there are some other graphs which are going to have x-intercepts. I'm going to consider one graph and specifically find actually x-intercept for it. Okay, just to show you how it works. F of x equals 2x squared minus 6x minus 8 equals 0. I'm thinking like, what are going to be my x-intercepts? Well, what I'm going to do, guys, I'm just going to use a formula. So remember that x-intercept happen when y equals to 0. Y equals to 0 means that f of x equals to 0. So you're going to put 0 here, 2x squared minus 6x minus 8. I don't want to deal with big numbers here. I see that I obviously can divide the whole equation by 2. Because this can be divided, this and this can be divided by 2. And my equation is going to be x squared minus 3x minus 4 equals to 0. I'm going to use the formula. Erase it. x12 equals minus b, which is minus 3 already, so it's plus 3 plus minus square root of minus 3 squared is 9 plus, because it's minus here, right? Formula has minus and there's one more minus. 2 by 4. Oh, no, not 2 by 4, 4 by 4 actually. 4 AC, 4 by 1 by 4, and divided over 2a, which is 2 multiplied by 1. So here 4 by 4 is 16, plus 9 is 25, and the square root of 25 is plus minus 5, right? And we are going to have 3 plus 5 is 8 over 2 is 4, and 3 minus 5 is negative 2, which is going to be divided over 2 and give negative 1. Okay, So these are going to be solutions and they're going to make intercepts. Here, I did not actually bring the parabola to standard form because I don't want to do like all this work. I just want to show you the intercept. So one intercept is 4. One intercept is -1. I don't know where is going to be the vertex, but I definitely know that the parabola is going to go like this through these intercepts. Can we find, so I'm going to write down x intercepts. X equals 4 and -1. Do we have y intercept here? Well, y-intercept happens when x equals to 0. If I set up x equals to 0 here and here, I'm going to just get -8, right? Y equals -8. So actually my graph is not very actually precise. The graph is going much deeper down. But I'm erasing here, finding where is 8. Okay, I don't want to do 8 all the way there. I'm going to do -8 here. So this is going to be my -1. That's where my intercept is going to happen. See? Okay, that's more precise graph of this parabola. Okay, now besides intercepts and besides standard form, what else we can have about parabola? If you look at these two parabolas, you're going to see that parabolas do have minimum value. This one, let me color it. What is minimum value of the parabola? Well, if you look over here, it happens at the vertex, right? So actually you can write down that f of -1 equals to 6. It's a minimum of this parabola. How about this one? Well, we actually don't know because we did not bring it as standard form. So we know that it's going to be the minimum somewhere here, but what is going to be exact value for the minimum? We'll need to bring it to standard form. Maybe we are going to do it later. But for right now, I'm going to just consider a ready parabola for minimum maximum example, and then we can find out what is going to be minimum maximum over here. Imagine that, well, minimum maximum values. Imagine somebody gives us a parabola f of x equals -x minus 3 squared plus 5. It's already in standard form. So what is going to be the vertex of this parabola? Vertex is going to be, this is h, right? And this is k, so 3, 5. So because we have a minus here, that means that parabola is going to be not going up, but reflected actually, and will go down. So let me kind of find the vertex and graph approximately this parabola, 3, 5. 1, 2, 3. Wow, for the 5, let me do the 5 over here, okay? I don't want to kind of go too high above for the 5. 1 unit here, 1 unit here. So my parabola actually goes like this. Again, how do I know it's going like this? Because it's a minus in front. Remember that minus in front of the function means that you are reflecting it about x-axis. So here, vertex is not going to be the minimum, but actually vertex is going to be the maximum, right? Because like parabola goes up, 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 and then goes down, and that's at top. So you can write down that f of 3 equals 5 is a maximum. Okay. Well, sometimes we'll need it. Now, guys, we are ready to do a general formula for the vertex, because completing the squares sometimes can be very long and you can do lots of mistakes in them. I'm going to do the vertex formula for you. And if you memorize this vertex formula, which is very, very short formula, it's going to be great for this class. General formula. And this general formula, besides vertex, is going to help us to find minimum and maximum values. Right? Parabola is never going to have both minimum and maximum. It's going to have either maximum like over here or minimum like over here. But it's always going to happen at the vertex. General formula for the vertex. Okay, I'm going to write down general parabola. This general formula is going to look very much like quadratic formula what I'm going to do, guys, I'm going to repeat the very same steps I was doing before with numbers, but I'm going to do them with letters now. So I'm going to consider these first two terms and take a outside of parentheses from both of them. From the first one, I'm going to have leftover x squared. From the second one, because I don't know if there is a inside of this b, I'm just going to divide actually b over a. And if I multiply back a by x squared, it's going to give me ax squared, and a by b over a will cancel and give me bx. On my next step, I'm going to complete the square here. We already know that this coefficient is kind of 2b for completing the square. So if we divide it by 2, we are going to know the third term. And that's what I'm going to have, b over ax plus b over a divided by 2 squared. That's a term which is missing for completing the square. Remember, well, it's unfortunately I have same letters over here, a, b, and c, but you have a plus b, a squared, let me make it a little bit smaller, plus 2ab. Oh, let me write it down like 2ba. That's going to be 2ba plus b squared. So we know that this is x, right? Whatever coefficient of x is 2b. So if you want to know what is b without 2, then you will need to take this coefficient and divide by 2. And that's what we did. We took this coefficient divided by 2. And that's going to be b, which we square here. To not change it, we are going to take b over 2a and square it again and subtract it. And then close parentheses and add this c. Next step is to complete the square. Just roll it. This is my x is my a, and this is my b. B over 2a. It looks like a little bit crazy because we have b and b, but this b is different from this b. Okay, this is complete square. And then we have this term with minus b over 2a squared plus c. And I'm going to open parentheses, a big one, this parenthesis. I'm going to open the multiply by a. So a x plus b over 2a squared, and then a multiplied by this expression, ab over 2a squared plus c. Well, guys, what we have, if we compare it to standard form, a x minus h squared plus k, we're going to see that my h is equal to this expression was minus, right? Because that's minus, and here we have plus, so it's obviously with minus. So I'm going to write down that h equals minus b over 2a. Well, this expression is going to be equal to k. I don't want to copy it, guys. The only formula I'm asking you to memorize, the formula for h. Why? Because if you set up your x equals to h, what is going to be actually f of h? If you set up x equals to h, it's going to be a minus b over 2a instead of x here, I'm using my h, plus b over 2a squared plus, and I'm going to copy c minus a b squared over 4a squared. I'm just kind of opening parentheses. You see that this parenthesis will give you 0. And it's going to mean that f of h will be equal to c minus, if I cancel a little bit, b squared over 4a. So that's my k according to like understanding of standard form. Do you need to calculate this k and memorize a big formula for it? C minus a multiplied by b over 2a squared. No, actually, you can always use your ready parabola and plug in your calculated h to find this k. So you don't need to memorize this formula. You need to memorize only this formula. I'm going to write down vertex of the parabola. Going to have coordinates minus b over 2a and f of minus b over 2a. Here, a shortcut is not memorize the formula, but just plug the numbers into your parabola. What I'm going to do, guys, remember I left one problem without vertex. I did not finish it. That was like a problem before. That's over here. I was asking like, what is the number here? Why don't we use this formula to calculate actually the vertex of this parabola? That's going to be my parabola, right? So what is going to be the vertex of it? The formula tells that h equals minus b over 2a. Well, what is my b? My b is minus 6, so it's minus 6. One more minus is going to give me plus 2, and a equals 2. So I have 6 over 4, or 3 over 2, or 1.5. That's going to be my x coordinate of a vertex. Y coordinate of a vertex, k, is f of this x coordinate and just h. So I just need to plug in 1.5 into this equation. Well, I think I'm going to plug in 3 over 2. It's going to be a little bit easier for me to use calculations. 3 over 2 squared minus 6 by 3 over 2 minus 8. Well, let's calculate what we are going to have. Well, 3 squared is 9, 2 squared is 4. So I have 2 by 9 over 4 minus 6, and 2 can be canceled, and that's going to be 3 by 3, 9 minus 8. Step left. 2 and 4 canceled a little bit, right? So it's 9 over 2. And here I have minus 9 and minus 8, which is going to give me what? Minus 17, I guess, right? And here it's 9 over 2. Doesn't look like 9, I think. I'm going to read it and write down 9 more clear. So what is 9 over 2? 9 over 2 is actually 4.5, right? Minus 17 is going to give me 12.5 was minus, right? Oh, just subtract using your calculator. 12.5. So the coordinates of a vertex are actually negative 1.5. Oh, not negative, positive 1.5, right? Sorry. Why did I write down negative? Positive 1.5. By the way, in the picture, it's almost. And over here, it's 12 minus 12.5, minus 12.5. Picture is not very correct, but this, I think this is supposed to be 10 and 12 is going to be somewhere here. So actually this parabola is supposed to go like that. Okay. So now for minimum, what we have? Minimum is actually the vertex, right? F of 1.5 equals negative 12.5. That's going to be the minimum of the parabola. Okay, please memorize the formula minus b over 2a. It's very, very helpful. And now what we are going to do, instead of completing the square, you can always use the formula. I don't know what is easier for you, to use the formula or complete the square. Sometimes I'll ask you to use special method like completing the square or use the formula. But for your future life, you can always use the formula. Now, guys, our topic was quadratic functions and models. Let's talk about models. What kind of models we have? Well, quadratic functions are usually helping us to solve minimax problems when you maximize or minimize something. For example, imagine that you have a river and you have a bunch of turtles and you want to make a fenced area for them. So there's a grass growing here, growing here, growing here, everywhere. You want to fence some area, rectangular, to keep your animals over here. And these are land turtles. Land turtles mean that they don't go to the water and they just going to be sitting over here. And you have a certain amount of fencing. Like imagine that the length of fencing is 2,000 feet. And they're asking like, what maximum area can we fence with 2,000 feet? Area maximum, what maximum area? How do we solve this problem? First, we're going to kind of imagine that we fenced it already. Imagine that you solve the problem. If it's rectangular, then if you set up x here, then this side is going to be x2. What is going to be this side? Well, we know that totally all three sides, I'm going to label this y, are going to be y plus x equals 2,000, right? Because we have only 2,000 of fencing. And y is going to be equal to 2,000 minus 2x, right? Because this is 2x, and if you bring it to that side, It's going to be 2000 minus 2x. Now, what is going to be the area of this rectangle? The area is going to be x multiplied by y, right? And that's going to be x multiplied by 2000 minus 2x. If you open this parenthesis, you're going to have 2000x minus 2x squared. And this is parabola. And they are asking like what x is going to kind of give you maximum area. So we'll need to find maximum of this parabola. Well, how we do this? We'll need to find the vertex. Vertex h equals, and still remember the formula, right? Minus b over 2a. So what is my b here? B is coefficient of x. It's 2000 minus, what is my 2a? 2, and coefficient of x squared is a. This is my a, and this is my b. So 2. And because it's minus, I'm going to put it in parentheses, okay? See, 1 minus and 1 minus, then cancel each other. And I have 2000 over like 4, right? And that's going to give me 500. So x is 500, y, the other side is going to be 2000 minus 2x, which is going to be 2000 minus 2 by 500, which is going to give me 1000. And the area is going to be the area. Let me write down the area actually. It's going to be equal, well, area is x by y, right? X is 500 and y is 1000. And that's going to be 5, 1, 2, 3, 4, 5, 5 zeros. 500,000 square feet. Okay, that's a maximum area we can do. Now, how do we know it's maximum, not minimum? Remember, I was telling that for parabolas, it's either maximum or minimum. Well, let's go back to our function over here, parabola. I'm going to write it down one more time here, copy it from over here. Minus 2x squared, I'm going to put quadratic term first, plus 2000x. You see that we do have the minus in front of x. Minus in front of x is going to mean that parabola is going to look like this, reflected about x-axis. So if parabola looks like this, then the top parabola is maximum, not the minimum. Okay, and that's all of today's lecture. Do your homework. There are a couple of problems like this in your homework. If you kind of cannot get through them, bring them in class. We are going to solve them in class. Okay, and thank you.